All right, welcome to the Ed Puzzle for this lesson where we're going to be talking about some trigonometric applications, where in this case we're going to have some real life contexts where when we're drawing our situation up, we end up getting multiple right triangles within one another. So you want to always just make sure before you start doing your trig that your calculator is in degree mode. So we go to our calculator, we click that mode button, and we make sure that degree is the one that is highlighted. Now, comparing these methods, we're going to be using trig to solve for a side and solve for an angle, which we have done before. This is nothing new to us. But we want to make sure we know that the information that we need in order to solve these types of problems, because it'll be easier for us to identify this when we're doing a problem. So using trig to solve for a side, you need one side and one angle of a right triangle. Using trig to solve for an angle, you need the value of two of your sides. So when you're solving for an angle, you need to use your inverse trig functions. Now, when do we see this? So there might be times where you have the base of your triangle, like that bottom side, that is broken up. And we want to be mindful of this because on the geometry regions, questions of this nature are typically 4 points. That's a lot of points, and they show up almost every single year. So we're going to work on, so in these three examples, you can see that the bottom of our triangles are broken up. Another example is if we have the leg of our triangle broken up. So instead of this bottom side here being split, we have this side here, and this side here being split. Other types of diagrams you guys might see, the Regents loves to use like steps as problems. Now in these cases, you just have a bunch of right triangles, like even here, right, in this second diagram that we have on the right, there might be times where we need to separate and draw, like we might have a right triangle with these measurements, or we might even stop here since we have that this value is d, we might even stop here and make a right triangle here, and then we have an even larger one right there. So these are just some things to get us warmed up. What should we do with these questions? Well, we always recommend that you guys draw your triangles separately. This is no different than when we do congruence or similarity. You always want to draw your triangles separately and in the same orientation. When you're drawing them separately, though, you want to be mindful of the angle measurements and of the side values that are getting carried over. Typically, they'll give you like a portion of a side or the smaller angle, right? So we got to be mindful of that when we're redrawing. And then we also want to be mindful of what our question is asking. So we might need to do something with our answer in this case. Now, again, this kind of goes along with step 2. You want to figure out if you can leave your answer as is or if you need to subtract it. So typically for these questions, you're always going to do trigonometry twice. You're going to do it once for each triangle, but then it depends. In some cases, you might be able to leave your answer as is, but in a lot of cases, you're going to have to subtract the two answers that you got. So we're going to just practice redrawing some of these. So we're going to redraw these two triangles where our base is broken up. So what I see a large right triangle here, so I'm going to go ahead and draw that. Now in that large right triangle, we have the 90-degree angle here, the 40-degree angle goes here, and then this here wouldn't be 85. It would be 85 plus x. Now the smaller triangle, we can do it in blue. That's going to be right. The smaller triangle we'll do in blue is right here. Now we have that right angle. We have an 80-degree angle right there. And then this would be our x value. So let's go ahead. I'm going to redraw the big triangle quickly. We had the 40, we had the 85 plus x, and we had our right angle. So here, depending on what the question asks you for, you can do trig twice with both of them. Now, in the second diagram, I'm going to go ahead and do the same thing. So it doesn't show us where the right angle is, but in real life context, we know that the right angle between like the flag and the ground is going to be right there. So here in red, we have 52.8 degrees right there. And then we don't have a value for that side, so I'm going to call that x. And then in blue, we have the larger right triangle here, where we have 90 degrees, we have 34.9 degrees, but then this side is not 8. Notice how when they give you that, that's only a part of a triangle. That's 8 plus x. So notice when your base is broken up, typically you have to make an expression. Like here we did 85 plus x, here we did 8 plus x. Typically you're going to have to make an expression when you're drawing your triangles. Also, I'll be mindful here too, they give us that the value off the ground for both is 1.7 meters. So I feel like that's going to eventually be useful depending on what they're asking us here. All right, in this example, we have our leg broken up. Now, we're going to have two right triangles, so I'm going to draw the biggest one that I see. I'll draw the smallest one first. Actually, it doesn't matter. I'll just draw this one first. So in my red triangle that I am drawing, we have a 90-degree angle, and this entire angle is 38.8 degrees. 38.8 degrees. Now in blue, if we redraw this triangle here, we have a right angle, we have 30 degrees, and then I can't really see that number right there. Oh, 440 feet. Now what's interesting about this is that the 440 feet is in both of your triangles. So this is 440, and then at the bottom of our blue triangle, we also have 440. And now again, depending on what the question is asking you for, we have this value of x here, but notice it's not a side of its triangle, a side of a triangle on its own. So what I would do is I would label this side as x and this side as y, and I feel like eventually we would have to subtract those. So if we take the larger value and then subtract this value, we would be able to get the x. All right, now I'm gonna have you guys try to do the last one on your own. All right, we're going to go ahead and do this one. So Cape Canaveral, Florida, is where NASA launches rockets into space. As modeled in the diagram below, a person views the launch of a rocket from observation area A, 3,280 feet away from launch pad B. After launch, the rocket was sighted at C with an angle of elevation of 15 degrees. The rocket was later sighted at D with an angle of elevation of 31 degrees. So basically what's happening is, at one point the rocket's here, and at one point the rocket is here. Clearly there are two different angles of elevation there. Now we want to know, what we're looking for is this distance. We want to know how much did it travel between C and D. So in this case, since the value that we're looking for is it's not a part of any of the right triangles. So if we redraw our right triangles here, let's draw the biggest one. It has a right angle, and this is a 31-degree angle here, and then 3,280 feet goes at the bottom. Then the smaller right triangle, which would be triangle ACB, the smaller right triangle, which is ACB, is going to have a right angle here, but then this angle is 15 degrees, and then the bottom is 3,280 feet. Now, I know, I'm not going to be able to use trig to get this side on its own, because it's not a part. DC, if you letter your triangles, this is ABD, and this is ABC. CD is not a part of a triangle in itself. So what we're going to need to do is find the value of DB first. Find this entire thing first. Then we're going to have to find the value of CB second. And then if we subtract those, if we take this larger value here and we subtract this value here, that would give us our remaining value of x. So I'm going to call this x and this y right now. I'm not even going to call that x. I'm going to leave that over. So in the first triangle, so this will be triangle 1, triangle 2. In the first triangle, I'm going to try to solve for side x. So I have my reference angle. I'm going to go ahead and make sure that I label opposite, adjacent, and hypotenuse. Now I know that my hypotenuse is irrelevant to me. I'm not using it. So if I write SOHCAHTOA, my trig function that I'm using is going to be tangent. Now tangent is a pretty common one to use. It's used a lot. So just be mindful of that. Tangent of theta is opposite over adjacent. Now if we make our substitutions, we have tan of 31 equals opposite, which is x, over our adjacent, which is 3,280. Now again, you can use the method of making your proportion. So if you put this over 1 and you cross multiply, you can do that. Or, well, we'll do that because we haven't really done that in the other videos. So if we cross multiply here, we get 30 to 80 times tan of 31 equals x. And now we know that once x is by itself, we can go to our calculator. And we've already made sure we were in degree mode, so we're good. So 30 to 80 times tan of 31 is going to give us 1970 point, I'm going to round it right now, so 823, but when I'm subtracting, I am not going to put 0.823 in. I'll show you what we're going to do after. Now in triangle 2, I realize this is getting a little bit sloppy, but just bear with us. In triangle number 2, again, we have our reference angle, we have opposite, we have adjacent, and our hypotenuse, we're going to label it, but it's irrelevant to us. There's no values there for it. So tan of theta, I know I'm using, is opposite over adjacent. So let's make our substitutions. Our theta is 15. Our opposite, in this case, is y. And our adjacent, again, is 3,280. So if we make our proportion here, and we cross multiply here, we get 3,280 times tan of 15 equals y. And then again, once we have our variable by itself, we go into our calculator. 3,280 times tan of 15 equals, we have 878.873. And this is in feet, equals y. So feet and feet. Now go back to our question, right? Remember, this value of our first triangle represented this entire side. So sometimes it helps labeling that, 1970.823 feet. And then this smaller value here is 878.873 feet. So again, what we said is if we take this larger value and we subtract the smaller one, we'll be able to get the distance of CD. But when you're doing that subtraction, we are not rounding yet. So what I mean by that is we need to do what we got in question 1 minus, so basically we need to do x minus y. What we got in question 1 minus what we got in question 2. Now I am not going to round. So what I got for x in your calculator, you can use this arrow. Go up and actually highlight and hit enter on the answer that you got for x. Then I'm going to hit subtract, and I'm going to scroll up, click the answer that I got for y, hit enter, and I'm entering that. We want to be as precise as possible, so when we do this, it's ensuring that we're not rounding until the very, very, very end. So the answer that I get when I do this is 1091, so 1091. And does it tell us what to round to? Oh, it does say, it says to the nearest foot. So I usually, before I even write my final answer, I'll still write 0.949 feet here, and then I'll draw an arrow and show that I am rounding, so it's 1,092 feet. So when it says determine and state, though, you need to write your answer in a sentence. So we would write, I'm getting a little sloppy, but the distance between C and D is 1,092 feet. So this would be your answer. When it says determine and state, you need to write your answer in terms of the context. So the distance, I would even be safe and say the distance of the rocket. The distance of rocket between C and D is 1,092 feet. Whenever it says determine and state, you need to say your answer in terms of the context. So use as many words from the context as you can to ensure your points. Now these questions can be very long, but you want to also make sure this work, I'm being a hypocrite, but I didn't have enough space, but you want to make sure your work is organized. Make sure that we can follow your work, and make sure that you are boxing in your answers, because these questions can get very sloppy. But notice, I box my answer so my grader can go there right away and see my answer, and then they can follow my work if they need to.